Hey there, in this video we're continuing to talk about rationalizing denominators, which is a method we use to get rid of any square roots that are in the bottom of a fraction. So we've seen that if we just have a single square root in the bottom of a fraction, what we can do to get that to cancel out is multiply times that same square root, because by definition of a square root, two of the same square roots multiplied together just equals that number, and we would be left with 5 times the square root of 3 in the numerator. Well, what if we have not just a single square root in our denominator, but something that has an integer plus a square root? So if we wanted to rationalize the denominator of this expression in orange, we're going to need to multiply by something a little bit more than just this square root of 3, because if we just multiply by the square root of 3, we'll still have some extra terms left over from this 4. Instead, if we have more than one term in our denominator containing a radical, we need to multiply by the conjugate. So the conjugate of an expression is what you get when you flip one of the signs in that expression. The conjugate of 4 plus the square root of 3 would be the expression 4 minus the square root of 3. So to rationalize the denominator of this expression, instead of just multiplying the top and bottom by the square root of 3, we would multiply the top and bottom by 4 minus the square root of 3. So let's continue that example on a new screen so we've got a little more space. Now when we're multiplying these conjugates in the denominator here, typically when we're multiplying things that have two terms times two terms, we need to distribute and multiply both of these two terms times both of these two terms. But there's a shortcut we can use only in the case that what we're multiplying is a conjugate of something, because when we have the opposite signs here in these second terms, we know that some of the terms from our multiplication are going to cancel out. So this shortcut works only in the case that we're dealing with conjugates, and we just need to do the work to multiply the first two terms times each other in the denominator. So 4 times 4 would give us 16, and multiply the second two terms times each other in the denominator. And positive square root of 3 times negative square root of 3 is equal to negative 3, because the square root of 3 times the square root of 3 just equals the number 3, and a positive times a negative gives us a negative. And that causes the radical that was in our denominator to cancel out. We would still need to distribute and multiply times both of these terms in the numerator. So in our numerator, we would have 5 times 4, and also 5 times negative square root of 3, so that's 20 minus 5 times the square root of 3, and in our denominator, 16 minus 3 simplifies to 13. So let's keep practicing that method with a lot more examples. In each of these problems, we want to start by finding the conjugate of the denominator, which is what we get when we keep the first term the same and switch the sign of the second term, and we'll multiply times the conjugate in the numerator and denominator. When we're multiplying two conjugates together, we can use this shortcut that works just for conjugates, that we only really need to do the work to multiply the first two terms times each other and the second two terms times each other, because those middle terms will cancel out. So in our denominator, we've got 10 times 10 is 100, and square root of 2 times negative square root of 2 gives us negative 2, because square root of 2 times square root of 2 is 2, and a positive times a negative equals a negative. In our numerator, though, that same shortcut does not apply. We still need to distribute everything in the numerator like it's a regular multiplication. So we're going to multiply 2 times 10 gives us 20, and 2 times negative square root of 2 is written like this, negative 2 times square root of 2. Now we can simplify the denominator. 100 minus 2 is 98. And whenever we're dealing with fractions, it's good practice to simplify, if you can, by looking for any common factors that you could divide everything in the numerator and denominator by. And every term in our numerator and denominator is an even number, meaning we could divide all of these terms by 2 in the numerator and denominator, and that would give us 10 minus 1 times the square root of 2 all over 98 divided by 2, which is 49. In this next example, we are going to start by multiplying times the conjugate, which is what we get if we keep the first term the same, but switch the sign of the second term. So instead of minus 5 times the square root of 2, we'll have plus 5 times the square root of 2. And when we're multiplying these conjugates in the denominator, we can use our shortcut. Just multiply those first two terms together. 10 times 10 is 100. And multiply those second two terms together. So here we're multiplying a few things. We're multiplying these integers together. Negative 5 times positive 5 is negative 25. And we're also multiplying these roots together. And the square root of 2 times itself is equal to 2. In our numerator, we have 7 times 10 is 70. 7 times 5 root 2 gives us 35 root 2. And it's looking like there will be some things we can simplify here. If we subtract those terms in our denominator, well, 25 times 2 is the same as 50, and 100 minus 50 is equal to 50. So we can also simplify our final answer here. Every factor in the numerator and denominator is divisible by 5. So if we divide everything in our numerator by 5, 70 divided by 5 gives us 14. 35 divided by 5 gives us 7. So we have 14 plus 7 root 2. And 50 divided by 5 gives us 10. And we'll move on to the next screen here, do a few more examples. So first, we've got to notice that the conjugate of our denominator will be what we get if we keep that first term the same, but switch the sign of the second term, and we need to multiply times the conjugate into the numerator and denominator. In our denominator, we can use our conjugate multiplication shortcut, the first two terms multiplied together, and the second two terms multiplied together. And now notice here, this example is a little different from the previous one because now both of the terms in our conjugates are radicals. So when we're multiplying a square root times itself, that square root cancels out and we're just left with the number. So square root of 7 times square root of 7 gives us 7. And square root of 5 times square root of 5 is 5, but since we have a positive times a negative, that will give us the negative 5 in our denominator. And in the numerator, we need to distribute and multiply square root of 3 times square root of 7 and square root of 3 times the negative square root of 5. And I'm just putting that negative in front of the square root of 3 because we had that negative on the square root of 5. When we multiply two radicals that have different numbers on the inside, we're going to keep the radical but multiply those numbers together. So that's one of the properties of the principal root. If we're dealing with the same number, like a times a underneath our square root, then the radicals will cancel out. But if we're dealing with different numbers underneath our square roots, like square root of a times square root of b, we keep the square root and multiply those two numbers together underneath the square root. So the square root of 3 times square root of 7 is equal to the square root of 21, and the square root of 3 times 5 is equal to the square root of 15, and we still have that negative in front. In our denominator, we have 7 minus 5, which gives us 2, and we cannot combine different square roots using addition or subtraction. So there is nothing left that we can do to simplify this. Although we are able to multiply together two different numbers using square roots, that is one of the properties of the principal root. We cannot combine together addition or subtraction underneath a square root. So this would be our final simplified answer. And let's continue here, look at another example together. So first we will multiply the numerator and denominator times the conjugate of the denominator. That means we're going to keep the first term the same, but switch the sign of the second term, and we will also multiply that into the numerator. In our denominator, we can use our conjugate multiplication shortcut. And when we multiply things that contain whole numbers as well as radicals, let's just take a closer look at what happens with these 3 times square root of 7 times itself. We want to multiply together the integers, the whole numbers, so 3 times 3 is 9, and two of the same radical will cancel out and we're just left with 7. And 9 times 7 would give us 63 in our denominator. If we do the same thing with the second two terms in our conjugates that we're multiplying, 9 times negative 9 gives us negative 81, and square root of 2 times itself is just the number 2. Now we have negative 81 times 2. Well, I know that 8 times 2 is 16, so 80 times 2 would be 160, and 81 times 2 would just be 2 bigger than that. So negative 81 times 2 is negative 162. So the denominator of this expression will have 63 minus 162, which gives us negative 99. Now let's continue this problem on another screen so we've got more space to work with our numerator. Now we saw that our denominator simplified to equal negative 99, so now let's continue and let's work with this numerator. When we're multiplying square roots times other square roots, if they're different numbers, then we will multiply them underneath the square root. So we have 3 outside of our square root, and inside of our square root we have 2 times 7. And when we multiply times the other term in our numerator, we have negative 9 times, well, square root of 2 times square root of 2 is just equal to 2. So negative 9 times 2. This gives us 3 times the square root of 14 underneath that radical. Negative 9 times 2 is negative 18, and we have negative 99 in our denominator. So this fraction has been rationalized. There are no more square roots in our denominator, but we should always try to simplify if we can when we're dealing with fractions. And every term in this fraction is divisible by 3, so let's divide the numerator and denominator by 3, and we'll get just the square root of 14 minus 6 all over negative 33. We could leave that negative in the denominator of a fraction, but it's usually more common to put that negative into the numerator of our fraction. So we could also write this as negative square root of 14 plus 6 in the numerator with positive 33 in the denominator.